We're given a demand function and a supply function, and our task is to determine consumer surplus and producer surplus at equilibrium. The first thing to notice is the form of our demand and supply functions. In both cases, we have quantity as a function of price. If we plot those, we'll see we would have price on the horizontal axis and quantity on the vertical axis. However, when we determine consumer surplus and producer surplus, we use the Marshallian supply and demand diagram. In that case, quantity is on the horizontal axis and price is on the vertical axis. In other words, what we need to find first are the inverse demand function and the inverse supply function. We start with our demand function as a function of price and solve for P. We multiply through by P. We'll have PQ is equal to 90 minus 2P. PQ plus 2P is equal to 90. Therefore, P is equal to 90 on Q plus 2. And now for the inverse supply function. We start with Q equals P minus 1 and solve for P, which is quite straightforward. We'll have P is equal to Q plus 1. Now we can solve for our equilibrium values of quantity and price. We have our equilibrium condition. Our inverse supply function, Ps of Q, is equal to our inverse demand function, Pd of Q. Q plus 1 is equal to 90 on Q plus 2. That implies Q plus 1 times Q plus 2 is equal to 90. So we have a quadratic here. It'll be Q squared plus 3Q plus 2 is equal to 90. Subtract 90 from both sides and then we can solve for Q. That gives us Q squared plus 3Q minus 88 is equal to 0. Do we want to solve for Q? We'll use the quadratic formula. We have the general form of our formula there, substituting in the appropriate values. Well, that implies that Q is equal to minus 11, or Q is equal to 8. Quantity is greater than or equal to 0. In other words, we can't have a negative value for quantity. So therefore, our equilibrium quantity, we'll call that Q star, is equal to 8. From our inverse supply function, we'll have P star is equal to Q star plus 1. That is 8 plus 1, 9. So we have P star, Q star, our equilibrium values equal to 9, 8. Now we have all the information required to calculate the consumer surplus and the producer surplus. Recall that to find the consumer surplus, we take the area under the demand function from 0 to Q star. That's this integral here. And then we subtract the green rectangle, P star times Q star. Consumer surplus is the integral from 0 to Q star of our inverse demand function of minus P star times Q star. That's the integral from 0 to 8 of 90 over Q plus 2 dq minus 8 times 9. We can simplify that. We have a quotient where the numerator is the first root of the denominator. So we can apply the integration by substitution rule for a quotient. And we'll have 90 times the log of Q plus 2, evaluated from 0 to 8, minus 72. That is 90 times the log of Q plus 2, which is 10, minus 90 times the log of 2, minus 72. Rounding to one decimal place, that gives us 207.2 minus 62.4 minus 72, and that's equal to 72.8. Recall producer surplus is the shaded area here. In this case, we start with the green rectangle, P star times Q star, and then we subtract the area under the supply curve. That's the integral from 0 to Q star of S of Q. And then what we're left with is the shaded area. Producer surplus is equal to the equilibrium price times the equilibrium quantity minus the integral of the inverse supply function, S of Q dQ, evaluated from 0 to Q star. In this example, that will be 8 times 9 minus the integral from 0 to 8 of Q plus 1 times dQ. It's equal to 72 minus 1/2 Q squared plus Q evaluated from 0 to 8. That's 72 minus 1/2 8 squared minus 8 minus 0, and that's equal to 32. And finally, stating our answers, consumer surplus is 72.8, and as we just found, producer surplus is 32.